Today we're going to finish the note page for the Chapter 8 core packet. Go ahead and pop the last page off of your core packet and fill in your name and period up at the top. Then you're going to write save for final. Do not throw this away. Keep this so that you have some great example problems to use when you get to the end of the semester. Question number 1 says divide each of the following polynomials p of x by d of x to write the quotient q of x, and then rewrite the polynomial in the form d of x times q of x plus r, which is the remainder. So we're going to take this polynomial, 2x to the 4th minus x squared plus 3x plus 5. First, we want to make sure it's not missing any terms. So we're going to look at the exponents. We've got 4th power. Oh, we're missing a 3rd power, so we need 0x to the 3rd minus x squared plus 3x to the 1st plus our constant 5. So we're going to take our first term and fill it in our first box. X goes into 2x to the 4th, 2x to the 3rd times. We're going to multiply that by -1 to get -2x to the 3rd. We need to get to 0x to the 3rds, so we need the opposite of this, which is 2x to the 3rd. Now we're going to divide x into 2x to the 3rd, and it goes in there 2x squared times. 2x squared times -1 is -2x squared. We need just one -x squared, so we want to add 1x squared here. Then we're going to divide x squared divided by x is x, and then x times -1 is -x. We need these two boxes to combine to get 3x, so we actually want to add 4x. And then 4x divided by x is just 4, and 4 times -1 is -4. So we want to see if we're going to have a remainder. So we're going to take our expected value and subtract our actual value. So our expected value is 5. Our actual value is -4. When we subtract a negative number, we actually get 5 plus 4, so our remainder is 9. We want to write it as the d of x, so that's going to be what we divided by, our x minus 1, times our q of x, which is our answer, so 2x to the 3rd plus 2x squared plus x plus 4 plus whatever remainder we have, which was 9, over our divisor of x minus 1. For part B, you're going to try part B on your own. You're going to know if you did it correctly when you get a remainder of 190 over x minus 3. If you get that, awesome. If not, that's when you need to ask for help. Question number 2, they want us to describe the transformation of each log from the parent function log base 6 of x. So what's happening? Something's happening here and something's happening here. This is telling us we're moving right 1 unit. And this is telling us we are moving down 5 units. Part B, you're going to try on your own. Question number 3, they want us to evaluate the following for the function of x, where x plus 2 is being squared minus 1. So what happens if we plug in I, our imaginary number I? We would plug that in wherever we see x, so we would have I plus 2 being squared minus 1. If we want to square this, you can use an area model. I'm just going to FOIL. Multiply I plus 2 times I plus 2, which gets me I squared plus 2i plus 2i plus 4, and then we want to subtract 1 from the whole thing. Now let's combine like terms and simplify. I squared is just -1, 2i plus 2i is 4i, and then 4 minus 1 is 3. So our final answer is going to be these two combined, which is 2 plus 4i. Remember, we do the real number first, then the imaginary number to get our complex number. Part B. Now we want to set this equal to 0. So if we take our x plus 2 being squared minus 1, set it equal to 0. Let's add 1 to both sides, which leaves us with x plus 2 being squared equal to 1. The inverse operation of squaring, we're going to take the square root of both sides, so that leaves us with what's inside, which is just x plus 2. When we take the square root of 1, we get plus or minus 1. Now we just want to subtract this 2 from both sides, so we get x equals negative 2 plus or minus 1. To get our final two answers, we take negative 2 plus 1, which is just negative 1, and then negative 2 minus 1, which is negative 3. All right, question C says we're going to graph the function x plus 2 being squared minus 1. Then we're going to find its inverse and graph it on the same axes. So you're going to see I already have my line of reflection here. I highlighted it. And then I'm going to fill out a table for both. You can get those on your graphing calculator. And then we're going to talk about inverse operations and write down our equation for our inverse. Let's do that first. So what's happening to our x here? First, 2 is being added. Then we're taking the square root of it. And then we're subtracting 1. So the inverse operations, we would do the inverse of subtracting 1, which is adding 1, the inverse of squaring, which is square rooting, and the inverse of adding 2, which is subtracting 2. So we're going to take our x, we're going to add 1 to it, then we're going to take the square root of that, and then we're going to subtract 2. Okay? So you can type the function itself into your graphing calculator, then type in the inverse into your graphing calculator and graph both of them. They're going to be roughly a parabola for the first one. Oh, it's crossing here at positive 3, so it's a little skinnier. There, more like that. And then like that. And then for the inverse, it's going to be on its side. And it'll only graph this much of it in your graphing calculator. We can assume that the other part of it is not going to show up in the graph. So when we look at the table, we're going to have a point at negative 4, 3, negative 3, 0, negative 2, negative 1, negative 1, 0, and 0, 3. For our inverse, we simply flip-flop these two tables. So this will be 3, negative 4, 0, negative 3, negative 1, negative 2, 0, negative 1, and 3, 0. Part 4 down at the bottom says solve each of the exponential equations. So we want to get this x by itself. I notice the whole thing is being multiplied by 5, so the first thing I'm going to do is divide by 5. These cancel, and I have 18 to the power of 6x, and then 25 divided by 5 is just 5. Then I'm going to rewrite my exponential using a log. So I'm going to have log base 18 of 5 is going to be equal to 6x. I'm going to want the x by itself. It's being multiplied by 6, so I'm going to divide by 6. Then I'm going to take my calculator, type that in, log base 18 of 5. You would need to do the change base. So you would go log of 5 divided by log of 18. Get that answer and then divide it by 6 with your calculator. And you should get something approximately close to 0.093. Part B, you're going to skip. All right, go ahead and flip your note page over to the back. On the back for question 5, directions say, describe everything you know about the following graph. What is it shaped? Well, it's kind of like a W. What is the degree? We have 1, 2, 3, 4 directions, so it's going to be a 4th degree polynomial. How many roots do we have? It's got 1. This is a double, 2, 3, 4. 4 roots. One of them repeats. What is the possible equation for this? This one is crossing at -3, 0. So it has a possible factor of x plus 3. This one's hitting at 0, 0. So it has a possibility of an x, and it's bouncing. So it has a possibility of another x. Then it's crossing right here at +2, 0. So it has a factor of x minus 2. To find the leading coefficient, we need to use another point, not on the x-axis, and we have one right here. It is at -1, -3. So we're going to use that to find our a. That will get us our leading coefficient, which is our variable a. So let's take this number in for x, this number in for y. So if our possible equation is y equals a times all these guys, x, let's do our x's first, x plus 3, and x minus 2. We're going to plug -1 in everywhere we see our x, and then we're going to plug -3 in where we see our y. And the only variable left will be our a. And that's what we're going to solve for. Oh, forgot my x right there. So -1 minus 2. Okay. So we've got -3 equals a. -1 times -1 is +1. -1 plus 3 is 2. -1 minus 2 more is -3. So we've got -3 equals -6a. Divide both sides by -6. And so our a value in this case is 1/2. So what is the final equation? Our final equation is going to be y equals 1/2, which we just calculated right there, times all of these guys right here. So we can call that x squared, because x times x is x squared, and x plus 3, and an x plus 2. All right, what is the end behavior of our graph? We're ending up on positive, so we're going to call that one positive infinity. What is our domain? It's coming from infinity going all the way to positive infinity. What is the range? Looks like the lowest point here is at about -8. So we're going to say the range is greater than or equal to -8. All right, question number 6 says, write the equation in AB to the x plus k if the graph passes through the point 114 and 320 with an asymptote of 12. So first, we need to adjust these by subtracting 12 from each of them. That makes this point 112. That makes this point 38. And we need to figure out our b value. So for our b value, we're going to subtract the x values, so 3 minus 1. And then under the root, we're going to take the y values and divide them. So 8, that should be 2. There we go. So 8 divided by 2. We've got the square root of 4, second root of 4, which is just 2. So that's our b value. Our starting value is going to be 0, 1. So our equation is going to be y equals 1 times 2 to the power of x plus our k, which is 12. And our last question, question number 7, complete completely solve the two triangles using law of sines, law of cosines, and triangle sum theorem. Round sides to the nearest 100.